All right, so the last two examples here for chapter 5, this is going to finish off our radical unit. So if you recall, we don't like to have square roots in the denominator. It's ugly, it doesn't look very nice, so we always try and get rid of that. Now, the way that we need to do this is we need to multiply by the conjugate. If you don't remember what a conjugate is, from yesterday's notes, notice here we multiplied by the conjugate and we got a whole number. Conjugate being the same first terms, the same last terms, and one's plus and one is minus. So if we multiply by something like this, we are going to get rid of that nasty radical in the denominator. And that's our whole goal with this. It might make the numerator more ugly, but at least the denominator is better. So for something like this, what I'm going to do is I'm going to times by this denominator, but with a minus instead of a plus. So I'm going to multiply by root 7 minus root 2 over, with on top of that, the same thing. So multiply the top and the bottom by root 7 over, or root 7 minus root 2. So the top part, multiplying that out, we get 4 root 7 minus 4 root 2 over, and on the bottom we get this, root 7 times root 7, so we get root 7 squared, and the middle term is going to cancel out. We'll have negative root 7 times root 2 and a positive root 7 times root 2. So I'm not even going to write that middle term because it's going to cancel out. And we'll end up with minus root 2 squared. So now we can do what that is on the bottom. So 4 root 7 minus 4 root 2 over 7 minus 2. Still expand that more. 4 root 7 minus 4 root 2 over 5. And that's going to be our final answer. Notice I cannot simplify anything else. I can't simplify anything from these roots. I can't divide out that denominator, so we're done. That's what you're going to do. Notice the numerator is worse. However, we've gotten rid of what was in the denominator, and that's the main goal, is to get rid of that ugliness in the bottom. Let's try another one here. Since I used up some space here, let's do this one. So again, we're going to multiply by the conjugate of what's below. So root 3 minus root 2 by both the top and the bottom. And we're going to get something ugly on top, but let's multiply this out. Again, let's multiply firsts. So root 2 times root 3 gives you root 6. Outside, root 2 times negative root 2. So negative root 2 squared. That one's going to be a nice number. Insides, negative root 3 times negative root 3. So again, negative root 3 squared plus root 6. Negative and negative will give you a positive. So there's the numerator. Let's do the denominator. Because it's the conjugates, I'm just going to get root 3 squared minus root 2 squared. Let's simplify as much as we can. So I've got a root 6 and another root 6. So we'll have 2 root 6 up top minus root 2 squared. So 2 minus 3 divided by 3 minus 2. Simplify this even farther. We get minus 2 minus 3 is minus 5. So we get 2 root 6 minus 5 over 3 minus 2, which is just 1. So you can leave it as 1 or just get rid of it, and this is your answer. So this looks less complicated than what we have up here. So this is good. That is when you have a weird denominator. So sometimes we have a more complicated numerator, although that last one was pretty complicated. if we're going to rationalize something like this, notice in these three examples, there is no plus or minus. This is great. This makes our life a whole lot easier. All I need to do is multiply the top and the bottom by the root to get rid of it. So I times this one by root 2 over root 2. So let's multiply this out. 3 times root 2 is 3 root 2 plus root 2 squared. Not too bad. Divided by, again, root 2 squared. So we'd get 3 root 2 plus 2 over 2. Done. There's your answer. I can't, please do not cancel these out. There's a plus sign here, so you cannot cancel that out. Only if everything is multiplied by the same term can you divide it out. Let's try this one. So for this one, you might be tempted to times by 3 root 2 over 3 root 2. I don't need that 3 in there. That's not going to help us at all because I just want to get rid of the root. So you just need to times by root 2 over root 2 to get rid of that. So we get 5 minus 2, 5 root 2 minus 2 root 12 over 3 times root 2 squared. So we had 5 root 2 minus 2. I can factor out this root 4 over 3 times 2, which this gives me 5 root 2 minus root 2 is root 4 is 2 times 2 is 4 root 3 over 6. Again, look and see if you can cancel something out with all the numbers. In this case, you cannot. I'll leave the last one for you. You can give that a try. So that concludes this unit. That is everything in the radicals that you need to know.